Welcome to the First Mold Insights, where we talk about injection molding, rapid tooling, product development, and real world manufacturing insights. Today's topic is injection mold bases, making and selection tips. Alex, we talk a lot about mold cores and cavities, the parts that actually form the plastic product. But there's this underlying structure that holds everything together, the mold base. Can you kick us off by explaining what exactly a mold base is and why it's so fundamental to the entire injection molding process?
Yeah, Mia, it's a great place to start. Think of the mold base as the skeleton of your mold. It's a crucial part, almost always made of metal, that's there to support and secure every other component of the mold. Its main job is to assemble and position all those parts, the cores, cavities, ejector pins, guide pins, exactly according to the design requirements. This ensures the whole mold stays stable and precise, whether it's just sitting there or actively processing parts. It's what allows the mold to operate normally, maintaining all that processing precision we strive for.
So, it's not just a block of metal, it's an engineered structure that ensures everything aligns and functions correctly. What does a typical mold base actually consist of, then? I imagine it's more than just one piece.
Exactly. It's a complex assembly. A mold base fundamentally includes a pre-molding system, a guiding system, and an ejection system. When you break it down, you're looking at components like the top clamp plate, the A plate, the B plate, and often a C plate, or what we call a spacer block. Then you've got the rear clamp plate, and then inside, the ejector pin plate and the ejector retainer plate, which are part of the ejection system, plus guide pins, return pins, and other bits and pieces that make it all work.
That's a lot of plates. Can you quickly walk us through the function of a few of those key plates? Like, what's the difference between the A plate and the B plate?
Sure. So the top clamp plate supports and secures the whole mold base to the machine. The A plate is where your mold core often gets fixed, or it might even be made of a high-quality material to directly form part of the product itself. The B plate typically fixes the other half of the mold core, and it can also extend the runner system. That's the path the molten plastic takes. Then you've got the C plate or spacer block, which supports the mold base and is directly related to how the product gets ejected. Its height, for example, influences the product's height once it's pushed out. And the rear clamp plate is literally what mounts the mold onto the injection molding machine.
Okay, so each plate has a specific critical job. It sounds like a lot of precision goes into making these components. Does First Mold or most mold manufacturers produce these mold bases in-house, or is it a specialized industry?
That's a great question, and it's actually where the mold making industry has really matured over the years. Most mold manufacturers, including us at First Mold, generally focus our efforts on the design and precision processing of the mold cavities and cores. We often outsource the standard mold bases to specialized producers. It's a way to leverage the production strengths of both parties, enhancing overall quality and efficiency.
Huh, interesting. So it's a division of labor to get the best outcome. Does that mean here is a standard range of mold bases available, or are they always custom made?
Well, you've got options. Mold makers can certainly purchase customized mold bases tailored to very specific mold requirements, especially for unique or very large projects. But what's becoming increasingly popular, and what we see a lot of, is the use of standardized mold bases. These offer diversity in design, much shorter delivery times, and are essentially ready for immediate use. They give mold manufacturers a lot of flexibility, which is a big advantage.
That makes sense for efficiency. So, when these specialized manufacturers are making a standard mold base, what are the key steps involved? And what kind of precision are we talking about?
Right. So for standard mold bases, the process is quite systematic. You start with bottom surface processing to get the initial dimensional accuracy. Then it's about aligning the workpiece and rough machining the 2D and 3D surfaces, things like non-installation or non-working planes. After that, you move to semi-finish machining, focusing on all the installation and working surfaces where stops go, where inserts fit, where springs sit, and so on. Guide surfaces and holes get semi-finished too.
That's a lot of meticulous steps. I imagine tolerance is incredibly tight.
Absolutely. After semi-finishing, there's an inspection, then fitter assembly operations. Before the final finish machining, you check insert allowances and align process datum holes. Then comes the finish machining of all 2D and 3D surfaces, the hole positions, datum holes, and height references, and a final pass on those guiding surfaces and holes. The whole thing culminates in another inspection to ensure everything is spot on. We're often talking about dimensional accuracy at the M level, meaning micrometers. It's incredibly precise.
Acrometer level for a foundational component like this, that's really impressive. What are some of the biggest challenges in achieving that level of precision for a mold base?
Well, aside from the obvious high precision requirements, you're often dealing with complex surfaces, even on a mold base, especially if it integrates parts of the molding. Think about some automotive covers or aircraft parts. Their molds have surfaces made of multiple curves, and that translates to complexity in the base too. Plus, molds aren't mass-produced. You're often making just one piece, so that means a lot of processing steps: milling, boring, drilling, reaming, threading, all for a single, unique item.
And I suppose the materials themselves add another layer of complexity?
Exactly. The main materials for molds, including mold bases, are usually high-quality alloy steel. For high-life molds, the requirements are strict, right from blank forging through processing to heat treatment. And that heat treatment deformation? It's a serious concern in processing that you have to account for.
So, what types of materials are most commonly used for mold bases, and how do you decide which one to go with?
The two main players are steel and aluminum alloy.
So, it's a trade-off then, strength and durability versus weight and thermal properties. How do product teams or mold designers make that choice?
You have to consider the mold's size, the precision needed, and the load requirements comprehensively. If the mold base's strength and stability are absolutely critical, you're going with steel. But if you need to reduce weight and have high thermal conductivity requirements, like for a small precision mold where rapid cooling is beneficial, then aluminum alloys are a fantastic choice. It's all about balancing those performance needs with the specific application.
That makes total sense. Now, let's talk about the design side. What factors really influence the structure of a mold base? I'm thinking about things that designers need to communicate to the mold base manufacturer.
Right, there are several critical factors. First, the cavity layout that's determined by the part's geometry, accuracy needs, batch size, manufacturing difficulty, and cost. It dictates the number and arrangement of cavities. Then, parting line determination is huge. Its position needs to facilitate easy mold-based processing, effective venting, smooth demolding, and good surface quality for the plastic parts.
So, a good parting line isn't just about the part, it's about the mold base's function too.
Exactly. You also have the gating system and venting system. That means the main runner, subrunner, gate shape, position, and size. Same for venting how and where the air escapes. Then there is the ejection method. Are you using ejector pins, ejector sleeves, push plates, or a composite ejection system. That dictates how the mold base needs to be configured to allow for core pulling or side recess processing. And you can't forget the temperature system. That's your cooling or heating method, including the shape and position of grooves and where heating elements are installed.
That's a lot of interconnected decisions. So, the mold base isn't just a generic frame, it's intricately tailored to the part's specific requirements and the chosen molding strategy.
Precisely. You also have to determine the wall thickness and overall dimensions of the mold base parts based on material strength calculations or empirical data. This defines the outer structure and all the connecting, positioning, and guiding component locations. And finally, you have to carefully analyze and calculate the strength of each part of the mold base to ensure it can withstand the forces during operation and maintain the working dimensions of the molded parts.
So, with all these types and custom options, how does a product team or a mold maker actually go about selecting the right standard mold base? It sounds like there's a systematic approach.
There definitely is. First, you need to test the adaptability of the selected mold base model with your injection molding machine. You've got to check things like the closed mold height and the open mold stroke. If it's not suitable, you simply have to go back and choose again.
That seems like a fundamental first check. And then, what about the size itself?
That's critical. Standard mold bases come in many sizes, and selecting the appropriate one is paramount. If it's too small, the mold base might not have enough strength or stiffness, or there might not be enough space for screws, pins, and guide bushings. Too large, and you're not only increasing costs, but also potentially needing a bigger injection molding machine than necessary. It's about finding that sweet spot.
So, you've checked the machine fit and the general size. What are the more detailed steps for selection?
Well, you start by determining the mold base assembly form based on the structural requirements of your plastic part. Then you determine the cavity wall thickness, either using a formula or based on experience. From there, you calculate the circumference size of the cavity plate. This usually requires some adjustment to get close to a standard size, ensuring there is enough space for other components like guide bushings. If there isn't, you increase the wall thickness dimension. Finally, you determine the thickness of the bottom plate based on your cavity depth and correct it according to standard sizes. With all those dimensions in hand, you can then select the specific mold base size from a supplier's catalog.
That's a really thorough process. It sounds like while mold bases are often outsourced, understanding their intricacies, materials, and selection process is absolutely vital for anyone involved in mold making or injection molding. It's the unsung hero, really.
It truly is, Mia. Look, just as a skyscraper must start from a solid foundation to stand tall and strong, building a solid mold base is crucial for creating an excellent mold structure that delivers reliable, high-quality parts. You can't underestimate its importance.
Thanks for tuning in. For more manufacturing resources or custom part production services, visit firstmold.com. We'll see you next time.